Hello everyone, I'm Bingjo. Welcome back to another video after so long. Alright, so as you can see, it's a different setting now. Yes, because I'm studying abroad and there's winter break now. So in this 1 month, I will try to upload as many videos as possible. Um, I'm planning to actually finish up the maths syllabus by this month and hopefully I can do it. So yeah, and in today's video and the future one or two videos, we'll be going into chapter 3 of the maths and we'll be talking about straight lines, the equation of straight lines, how do you get a gradient, how do you find the gradient, how do you find perpendicular lines given a gradient, and so on. So particularly in this video, we are going to be looking at three parts, all right? So the first thing, I'll be introducing to you what is, oh no, I don't like this ink. Let's go with this first. Alright, so in this video, the first thing I'll be introducing to you what is a Cartesian plane. Alright, and after that, we will be looking for gradient given two coordinates. Okay, and then after that, we will be looking at the length and midpoint between two coordinates. All right, so just by looking at this, I can kind of expect that this video is going to be a relatively short one. So without further ado, let's go in. All right, so first thing first, what is a Cartesian plane? A Cartesian plane is okay, I don't know what's the exact definition, but what you need to know is in IGCSE Maths, we'll be looking at the XY plane. All right, and this is actually a two-dimensional one. All right, and when you go up to higher levels like A levels and so on, you will be looking at XYZ plane. All right, and this is a three-dimensional one, and I think it's kind of irrelevant now. So what is oh no, I've been too long not using this. Okay, so you might see a plane drawn like this. This is the y-axis and this is the x-axis, and this is the basic xy plane. All right, you have the origin, which is 0. So when x is 0 and y is 0. So how do you read a coordinate out of a plane? All right, so at this point, okay, at this little small cross here, you can see that if you read y is equals to 0 and x is equals to 0, so this is called the origin, all right, which consists of 0, 0 as the coordinate. So what does the 0, 0 mean here? This represents the x coordinate and this represents the y coordinate. Okay, it's just that simple, and this is the Cartesian xy plane. So to give another example, let's say you have a point here, okay, and this is 5 and this is, let's say, 3. Okay, and we name this point A. Okay, so the question will be, list what is the coordinates, okay, of A. Okay, so if you understand how to read on the Cartesian plane, so you know that you will start with a bracket, and then the first number here will be what is on the x-axis. All right, so this is the x-axis, and for point A, if you go directly straight down, you will get a 5. All right, so the coordinates of A starts with a 5. Then you have a comma, then it goes to the y-axis. So the value of y of A is 3. Okay, so this is the coordinates of A, 5 and 3. All right, it's just that simple, and this is how you read a coordinate of a Cartesian plane. Okay, so the second agenda for today, after introducing to you what is a Cartesian plane, will be how to find a gradient of a straight line from two coordinates. All right, so the first question will be, what is a gradient? All right, there are a lot of different definitions depending on what you're actually referring to. So in this mathematics case, the gradient is the slope of a line. All right, so it actually defines as the change in value of y due to a change in x. All right, in other terms, you will see dy over dx, which I'm pretty sure that I kind of explained this before in the differentiation video. I'm not sure, it had been like 8 months, but I have a memory of saying this before. So d means delta. I'm technically it's not delta, but yeah, it's the change in y due to a change in x. All right, so for every change in x, you will see a change in y, and what is the rate of changing. Yeah, so you can say the gradient is the rate of change. All right, so back to the agenda for this one. We need to find a gradient. Oh yeah, and we will denote the gradient as m so that we can say it faster next time. M. All right, usually you will see m in a lot of ways describing as a gradient. Okay, so in a very nice Cartesian plane, xy. Oh my gosh, this is not nice. Just give me a second. Okay, y and x. All right, so let's say this point is 2 and 3. Okay, and this point right here is 10, and this point right here is 7. All right, it's just a sketch. Okay, so first thing first, the question will ask you to find the gradient. All right, so what is the gradient of this between these two coordinates? Okay, given that this is coordinate A and this is coordinate B. Okay, so the gradient is the change in y due to a change in x. All right, so it's the change in y due to a change in x. So for coordinates A, what is the coordinate of A? Okay, the coordinate of A is 10 and 7. All right, so it goes with the x coordinate, then the y coordinate. After that, it will be B. B is 2 and 3. So now you are to look for the gradient, which is a change in y. So what is the change in y from this coordinate to that coordinate? So we're going to say the y of this B minus the y of A. Okay, and the whole thing will divide by the change in x, which is the change in x coordinate of B minus the change in coordinate of A. Okay, so if you see this is actually makes sense. You don't have to memorize this, you just need to know what is a gradient. All right, the gradient is the change in y over the change in x. All right, so y of B is 3, and then y of A is 7 minus 7 divided by x of B is 2 and x of A is 10. All right, so by simple calculations you will get the answer as 1 over 2. All right, so the gradient is 1 over 2. And what does this mean? Okay, what does the gradient of 1 over 2 mean? So you can actually understand understand this as for every 1 unit change in x, 1 over 2 unit will change in y. All right, because the gradient is the change in y due to a change in x. So a change of 1 over 2 units of y due to 1 unit change of x. All right, so for every 1 unit change in x, half unit will change in y. So if you see from here, let's say these 2 points connect a straight line. Okay, let's say if these 2 points connect a straight line here, if you have a tree here, okay, then you will know, since this is a linear straight line, 1 unit change in x corresponds to half a unit change in y. So you can know the y value will be 3.5, which is 7/2 straight away. All right, and this is the definition of a gradient. Okay, and how do you look for a gradient from two coordinates? Next, the third and final agenda for today, we are going to be looking at length and midpoint. All right, length and midpoint. All right, so the length between, okay, I need to add this, between coordinates. All right, so the length, by the name itself suggests, is the distance. Okay, length will be is the distance between two points or coordinates. All right, coordinates is too long, so I'm just lazy to write it. Midpoint is the point which is equidistance between the 2 points. All right, so I'll explain more in a second, but first let's go on to length. All right, so from the Cartesian plane right here, y, x. All right, if you're gonna use back the same a, which is give me a second, 10, 7, and 2, 3. All right, 10, 7, and b right here is 2 and 3. Okay, so I'm sorry, I did not silent my phone right here. Okay, so first thing first, we're going to be looking for the length, which is the distance in between. Let's use this color. All right. Okay, so we need to look for the distance between the 2 points. So there is a formula for this. I'm going to be listing down the formula first. Okay, so the distance, or if you want to say its length, is x squared plus y squared, and you square root it. All right, and this is a general formula for any distance that you will see, maybe. Or if you know Pythagoras theorem, then you will know something like a squared is equals to, a squared plus b squared is equals to c squared. All right, something like this. And then if you are to look for c, all right, this is something like this. This is c, this is a, this is b. You want to look for c, which is the length, then you would be given square root of a squared plus b squared, something like that. Similar, and yeah, similar. So this is the general formula of a distance, so we now know. But how do you look for the distance in between two coordinates? Okay, so it will be derived such that it will be equals to the distance between x of a and x of b squared plus the difference in distance, well, the distance in between the y coordinate of a and b squared. It's just that simple. Okay, so if we are gonna be looking at the diagram above, so x of a is 10 minus x of b is 2, so you will square it, plus y of a is 7 and y of b is 3 squared, and you will square root the whole thing. Okay, and you will be getting an answer of 64 plus 4. So 64 plus 16, then you will get something like a cert 80. Let me double check. 8 squared plus 4 squared. Yeah, cert 80. All right. And if you want to further simplify it, there are a lot of ways to do it, like it'll be equals to 4 sub 5, but it's about maths. All right, if you are taking maths, this might be a very, very good chance for you to see whether you know how to convert cert 80 to 4 cert 5. All right, it's just something that I'll be showing you in the far future. I don't know when I'm gonna start doing maths. All right, so this is how you look for the distance in between 2 points. All right, there are a lot of theory in between, but I think the most important thing is you will remember this formula right here. How do we use this highlight here? It's just ugly, never mind. You need to know how I think you probably just need to know this formula right here. Okay, it's not hard to memorize actually. It's just remember the Pythagoras theorem and make the a and b to x and y's. Then it will just be the difference in between the first point and the second point of x, and goes the same to the y. You do everything into the formula, then you get your answer. Easy marks. All right, so next thing we'll be looking at midpoint. Midpoint is the point in the middle between two lines, such that from the previous example right here, y and x, we have 1 point here and 1 point here. So when you draw a straight line here, oh no, this is not straight. Okay, I have an idea. Straight line right here, okay? So this point in the middle here, this is the midpoint such that these two have equal length. All right, so this point right here, we call it M. This is B, this is A, and the midpoint M, all right, is the point in the middle between the two coordinates such that they have equal length. Okay, so how do we get this? And I'll just list down the formula first. The formula for midpoint is equals to xa plus xb divided by 2, ya plus yb divided by 2. It's just that easy. All right, and remember, midpoint is also a coordinate. So you will have the midpoint answer in the coordinate form. So for the x part, you would just be averaging the distance between the first and the second coordinate point, and same goes to the y. Okay, so same thing, if you don't actually remember the theory, you can just memorize this, as I believe this is not too hard to memorize. All right, it's just 1 point plus another point divided by 2. All right, so if we are going to be subbing it in with our example, A is 10 and 7, B is 2 and 3, I suppose. Okay, this will be equals to xa is 10 and xb is 2 divided by 2. Ya is 7, yb is 3 divided by 2. Okay, so in this simple mathematics, we will get 6 and 5. All right, which means this m right here is 6 and 5. Okay, so before I end this video, I would like to actually just prove to you this is the midpoint for A and B. All right, from what I said just now, midpoint will divide two coordinates such that both of them will have equivalent length. All right, so we are going to be proving that this is the midpoint by calculating the length of BM and AM. All right, so if we are going to be listing down here all our coordinates, all right, A is equals to 10, 7, B is equals to 2, 3. And the midpoint that we found is 6 and 5. All right, so we will be testing if AM is equals to BM. Okay, and by the way, this little modulus right here is technically it is a modulus, but we say that it's a distance symbol. All right. So first thing, we'll be calculating AM. Okay, I think it's okay if you don't put the modulus, but for safety, you can just say distance of AM, all right, in your exams, so that your teacher have no reason to minus any of your marks for saying, AM is not the length or anything. Okay, so distance of AM, as we said, is 10 minus 6 squared plus 7 minus 5 squared. All right, this I recommend you to remember this formula such that when you see any of the two coordinates, you can just straight up in your mind, you know that it's 10 minus 6 squared plus 7 minus 5 squared, and then you need to square root the whole thing. Okay, then you will get something like 16 plus 4, which is equals to cert 20, which is equals to 2 cert 5. All right, you don't need to actually know how to make from cert 20 to 2 cert 5, because in your exams, for maths, if I'm not mistaken, they will usually ask you to give your answer in 3 significant figures or 3 decimal places, and so on. And remember, it's important for you to write in 3 significant figures if the question asks so. All right, because I remember my maths teacher once told me in maths exams, you cannot leave your answer in cert form. So you always have to change it into decimal places. So this is one thing that you need to remember. For safety, just use decimal places. All right, so we found that the distance of AM is 4.47. Now we are going to be looking for distance of BM. Okay, which is equals to x of b, 2 minus 6. 2 minus 6 squared plus 3 minus 5 squared. Okay, and you will get down to the same working right up there, 16 plus 4. Okay, and you can go straight to the answer. It's equivalent to 4.47 in 3 significant figures. All right, so we have proved that AM is equals to BM. All right, okay, I'm just going to write this in a neater way and in a different color. Since AM is equals to 4.47 is equals to BM, we proved that M, which is equals to 6 and 5, is the midpoint of A and B. It's just that easy. All right, so yeah, this marks the end of the video. For this video, we had I had introduced to you how to read coordinates from Cartesian planes and an XY plane. All right. Second, I introduced to you how to look for gradient between 2 points, and thirdly, I introduced to you how to look for length and midpoint between 2 coordinates. All right. So in the next video, we're gonna be learning about how to form equation of straight line, how to form a line parallel to a given straight line, and perpendicular lines. And next video will be very interesting. So yeah, hope this video helps. Thank you for watching, everyone. See you guys next time.